Welcome to Mathematics with Tom. I'm Tom, and today we're going to take a look at a few derivations of Laplace transforms. So here we go. The first one we're going to look at is we're going to find the Laplace transform. Actually, let me just write in general. Remember that the Laplace transform of some function, say y of t, is equal to the integral from 0 to infinity of e to the minus st y of t. And y of t dt, and we call that result y of s, capital Y of s. So if it's the Laplace transform of f of t, we'd end up with a capital F of s. Now, let's find, remember this, we have found that the Laplace transform of y prime of t, we said that that was equal to s times capital Y of s minus the initial condition. All right, we might need that. Let's try to find the Laplace transform for y double prime of t. And I'll probably just be writing just y double prime. It's always implied to be t for the rest of the problem. So here we go. This says this is the integral from 0 to infinity of e to the minus st y double prime dt. And the only way to deal with this that I know of initially is to integrate by parts. Integrate by parts. Integrate by parts. Let's see, one of our parts is going to be that u is equal to e to the minus st, but that's going to give us that du is minus s e to the minus st, and our other part comes from dv, and that's going to be the y double prime dt, and that gives us the part of v is equal to y prime. Okay, I think we're ready. So let's try to write this. The Laplace of y double prime is going to equal to the u times v. So u is e to the minus st times v, which is y prime, evaluated from 0 to infinity, minus the integral of v du. I'm going to write the order in the other way. V is y prime, du is minus s e to the st. So minus s e to the minus st times y prime dt. Oh, whoops, du should have a dt on it there. Okay, and then when we evaluate this, e to the minus st evaluated at a large number is 0. So then we're going to pick up a minus. If we evaluate e to the minus st y prime of t at 0, we're going to pick up a y prime of 0 because e to the minus s times 0 is just 1. And then we're going to have a plus s times the integral of e to the minus st y prime dt. Now look at this. This is equal to minus y prime of 0 plus s times, this is the Laplace transform of y prime. That's its very definition. Well, this is equal to minus y prime of 0 plus s times, and then let's just use what we already said up above here in our highlighted color. We said that Laplace of y prime of t is sy of s minus y of 0. So let's write that. So s capital Y of s minus y of 0. And so the Laplace of y double prime can be written as s squared capital Y of s minus s times y of 0 minus, oops, there should have been a prime there, minus y prime of 0. Okay, so you know what? Just for the heck of it, let's try the third derivative. Let's try the Laplace transform of y, of y triple prime of t there we go, y triple prime of t. Well, that's the integral from 0 to infinity, and you might see a pattern here, e to the minus st y triple prime dt. And we're going to we're going to integrate by parts. So we're going to integrate by parts. And our parts are parts of, see, our u, again, we'll use the e to the minus st. So that's going to give me du is minus s e to the minus st dt. And our other part is going to be dv. Well, dv, let's see, for dv, we're going to use that as our y triple prime dt. And so then that's going to give us, that v is y double prime. There's our parts. So let's try this. So the Laplace transform of y triple prime of t is equal to u, that's e to the minus st, times, let's see, u times v. V is y double prime with our, and then our limits of integration from 0 to infinity, minus the integral of minus, I'll write it, yeah, we'll write it this way. So this is the integral of, I'll write it this way. So uv minus v. V is y double prime. Du, that's minus se to the minus st dt. Let's do some cleanup now. This is equal to, well, when you evaluate this at infinity, we get a 0. Then we're going to pick up a minus. E to the 0 is going to be a 1. So minus y double prime evaluated at 0. And then we're going to get this. We're going to get this plus s, the integral. I should have my limits there. The integral from 0 to infinity of e to the minus st y double prime dt. Well, wait a minute. Look at this. Look at what just happened. This integral right here, that is the integral right over here. That's the Laplace transform of y double prime. And fortunately for us, we know that. So let's plug in all that we have. We have a minus y double prime of 0. And the Laplace transform of y double prime is this one right down here. So let's just substitute that in now. Okay. So this is going to be plus s squared, capital Y of 0, minus s y. Oh, whoops. Need an s on all that. Goodness. Plus s times s squared, capital Y of s, minus s y of 0, minus y prime of 0. Wow, that's a lot of terms to keep track of. If I clean this up, we would write it, I'm going to write it in decreasing terms of s's. So s cubed, capital Y of s, minus s squared y of 0. Then I'm going to have a minus s y prime of 0. And finally, we're going to have a minus y double prime evaluated at 0. And that is the Laplace transform of both the second and third derivatives. I hope that helps. Thanks for watching.